Everyone that has an LPG vehicle has something similar to this. You've got a little push button thing which tells you if your gas is on or off, and also some LEDs which show or attempt to show the tank level. These are not very good, generally not very accurate. You've got no way to calibrate them. So if you've got any kind of knowledge of using Arduinos or something similar, it's actually dead easy to make up a little screen to your own little screen to display this. Now you could use, this could be an LCD screen, it could be a little OLED screen. You know, I could fit a little OLED screen in there, which would just display the rough sort of tank levels. Or in my case, because I've created this camper controller system where I've got these little touch screens, because this is running as a camper van as well, kind of. I thought I'd just display it on this this little screen here on the cab. Forgive the terrible bezel work, it's just a bit of dye bond that I've ground out. I need to get some clever board to 3D print me something nice. Any offers, get in touch in the comments below. So what I've done here is I've just created an element on the touchscreen here that displays the range of the where the LPG is sitting in the tank, and also a traffic light system, green, amber and red, depends on the level. So it just gives us sort of a visual indication. I'll probably change this a bit because, you know, the white on green background with the text, it doesn't really show up very well, but you get the idea. So I'll show you how to hook up or take a reading from the sender unit at your tank. This will work for just about anyone's. You've just got to take a couple of measurements and bring it into the Arduino so the Arduino can read it, and then how to display it on, well in this case it's an X-Day touchscreen display, but you can use an OLED, you can use an LCD, anything like that. If we want to take our own readings from an LPG level gauge, this is the sender gauge on the tank. This is a 95 litre tank. It's just resistance. You've got this little gauge here, they're all pretty much the same, and there's like a magnet inside the tank, so there's a level thing inside the tank, and near the surface of the tank here there's like a magnet which goes round, which picks up on a metallic part in the back of the gauge. They all kind of work the same. You can take this gauge off just with that screw, I didn't bother. So if you can find out the resistance range, most sender units are under 100 ohms, but some go to 60, others go to, you know, whatever. Through my 30 seconds of research on the internet before doing this, you can calibrate this pretty accurately, and I've tried this. So it's just two wires. I've just soldered them on there. You can look up your gauge, or you can take your gauge off, put an ohm meter on these two wires, and move the needle to full, move the needle to empty, take some readings along the way, make sure it's linear, and it's really as simple as that. So how this then hooks up to an Arduino is we send, this is the green and white wire coming in from the sender unit. I've just done this little breakout board here. This does voltage. There's a couple of voltage dividers there on the left in that green block, for monitoring the main and auxiliary batteries. But this blue block here, we've got the two green wires coming in from the LPG sender. Now this is a 95 ohm gauge, sender gauge, on that tank. So I've put 100 ohm resistor in. The closer you can get to that, your maximum reading, the more accurate it's going to be. So if you had a 60 ohm sender gauge, stick a 60 ohm resistor in here. So we're looking at the red and the blue wires here. So the red sends 5 volt out through the green from the Arduino using a Mega here with a shield, and it's coming back in, going through, in this case, a 100 ohm resistor, because 95 ohm is the maximum of the sender gauge, into the blue wire, which goes into an analog pin, whatever analog pin it is, can't remember. And then it's just a simple bit of code there, and then you can do what you want with that. Display it on an OLED, an HMI, you know, create buzzer alarms, whatever you want to do.
So here's our code. We start off in the Arduino sketch defining some timing intervals. This is how often we're going to read the variable resistor in the LPG tank. We don't need to take readings every seconds and stuff like that, you know, even if you're, you know, regardless of what you're using your tank for, whether it's for driving, if it's an LPG vehicle, or if you're using it for cooking, etc., or heating in your van, you know, it's not going to go down every few seconds. So I've got this set to every minute. You know, I could probably change it to every 5 minutes, truthfully. But that's fine. You know, the overall, you know, it's not putting any kind of stress on the processor. And this is with the timing as well. So next thing we need to look at is down here, we're defining some pins, analog pin, analog 6, because we're in effect taking that resistance reading. R3 is our resistor, 100 ohms. And we're putting 5 volts in, so we're just defining this. Then right down to the bottom of the sketch here, because this is the main camper controller sketch. The timer function, or the timer calls this function every minute. You know, less than a minute. This isn't run, so this only runs every minute, or however it's defined. And we're doing the calculation here. We have got a delay as part of this, and then it's just printing it out to the next in display element F0. So if the resistance is greater than 75, we're going to print to F0 in the next in display, and got that 75 to 93. I'm printing a range, you know, it's just this text is being sent to a text box, which is element F0. I could put, you know, actually display the reading there, but I've, you know, the actual resistance reading, and it would be fairly accurate. But don't forget, you know, if you're driving along, this is moving around a lot, so you could be going over a bump. If you imagine an arm inside the LPG tank, which kind of floats on top of the liquefied gas, you could be going over a bump, and that could read high, you know, when it's maybe only a quarter full at that particular time, and then, you know, a minute later it could read really, really low. So by doing this, it's more of a sort of averaging technique. You know, there's other ways to do this. So yeah, if the resistance then is between 55 ohms and 74 ohms, it then reads 55 to 75. Again, we're changing the colours here. If you've looked at some of my other videos with the camper controller, we've got text boxes that we can change the background colour. So we've got a traffic light system here. So green, amber, red, depending on how full the tank is. And this is what this, so we're as part of this if statement here, we are changing the BCO background colour, and that's specifying the colour of that number there of element F0. And that's really how it works, so on and so forth. So that's the Arduino code. I've got a few conditions there, and it goes right down to, you know, if the resistance reading is less than 14, it will change the background colour to red and actually print the text fill on the little indicator gauge.
So how well does it work? It works really well, in fact. I'm taking a reading every minute as per the code there that we're showing you. And occasionally, you know, if you're on a bumpy road, you know, at that point in that minute, it will show that it's, you know, the float's maybe, you know, gone elsewhere, you know, and it's not that accurate. But over time, you're driving along, you've got a fair idea of how much gas you've got. You may get a bum reading, which, you know, the LEDs can do the same. But no, it's good. And the other great thing is you can calibrate this just by adjusting the code in the Arduino. So as before, unlike these, you're kind of stuck with it. You know, I've had a lot of LPG vehicles over the years, and what I've found is that, you know, if you've got 200-mile range, you'll have 4 LEDs for, you know, the first 140 miles, and it'll quickly rapidly progress down through 3, 2, and then suddenly it's, you know, you kind of get a feel for that, but it's rubbish, you know, and there's no way to adjust that. So by doing something like this, as I've said before, it doesn't need to be a fancy touchscreen display. It can be a little OLED module, which you can you know, pop round here or whatever. Very, very smart, and they cost, you know, 5 or 6 quid. You know, this doesn't have to be an expensive project. You know, you'll get an Arduino for 3 or 4 quid. Make up a little voltage divider or a little ohmmeter circuit with a resistor, obviously sized to whatever to match the sender unit of your tank, and away you go. So hope you found this useful.